Hi, everybody. Good morning, good afternoon, or good evening, depending on where you are in the world. Thanks so much for joining us today. I'm Jason, the VP of Business Development here at SuperAnnotate. Today, we have a very special webinar where we will be joined by our good friends at Databricks to discuss how to derive business value from LLMs and RAG. Today's key speakers will be Quinn Leung, Senior Software Engineer for ML Training from Databricks, and Leo Linden, ML Solutions Engineer at SuperAnnotate. Just as a small housekeeping item, in order to make sure we have enough time to cover everything, please enter any questions that you have into the Q&A area, and then we will get to those questions during the Q&A portion of the webinar towards the end. Next slide, please. For those of you that don't know us at SuperAnnotate, our mission really is to accelerate the pace of generative AI innovation. We were founded in 2018 and have been recognized as one of the top 100 AI companies in the world. And we are the leader in our space, according to G2. And we've really loved working with some of the best companies in the world, from the world's oldest and most respected technology companies to rapidly scaling startups, and of course, to leaders in the enterprise machine learning infrastructure space, like our good friends at Databricks. Next slide, please. And so a little bit about the SuperAnnotate product. Now, our product offering really sits at sort of the core intersection of the data infrastructure lifecycle for Gen AI. The platform really gives companies the ability to fine-tune data for any Gen AI use case, now more easily than ever. It allows folks to deeply explore and curate data sets, to automate and orchestrate even the most complex data pipelines for AI, and also to find, highly skilled and expert workforces for Gen AI. And now, of course, I'm sure everyone on this call knows Databricks, but I'm happy to pass it on to Quinn to introduce Databricks further.
Hello, it's great to meet you guys here and talk about LLMs. My name is Quinn. I'm working in evaluation and fine-tuning of language models and RAG apps in Databricks. So a very quick intro about Databricks. Databricks is a unified data and AI platform that invented the data lakehouse concept. It's being recognized by Gartner as a leader in both cloud data management system and also data science and machine learning platform. So we created many popular data and ML frameworks like Spark, Delta, MLflow, and many more. And we have more than 6,000 employees with more than 10,000 customers and more than 1 billion ARRs. So what is Lakehouse? So next slide, please. Let's take a closer look. So a lakehouse architecture combines the advantage of both data lake and data warehouse. So that's why it's called lakehouse. So you can have a unified layer of governance, security to develop and run all the applications across all the major clouds like AWS, Azure, GCP. And this unified architecture supports use cases across the whole business cycle, like data cleaning and business intelligence to run the weekly, daily reports, and also predictive analysis through machine learning. And now we're getting to the next use case that grows exactly from the data platform to generative AI, where you can use your high quality data to train or fine-tune a language model that truly know your business and help to provide a better user experience to your customers and also help your employees to be more productive through all the LLM-powered tools like Copilot Assistant. So I hand it over back to Jason to talk about more language models. Next slide, please.
Yeah. Hi, everyone. So as Jason previously mentioned, my name is Leo. I'm a machine learning solutions engineer here at SuperAnnotate, and I'm going to cover some of the both foundationals around language models now, some of the use cases, and of course, some of the issues and problems one might bump into with this. So generative AI is all the rage at the moment, but what is it really? It is, as the name suggests, kind of systems that can generate content, be that image, text, video, and other types of modalities based on inputs and prompts. And large language models is the subset of these generating text. And in general, it kind of based on a piece of text, it will predict upcoming words or tokens, and therefore, as language is what most of us communicate with, have lots of massive use cases and implications. The process, the generic process to creating one of these language models are just like many other machine learning models. They're trained on predicting a specific class or label for some type of input. So a basic example could be a general image model where you might have an image of a cat or a dog. You train this model to predict, that label. Is it a cat or is it a dog in this image? But for large language models, you instead give it this huge chunk of text and you ask it, what is the next piece of word here? And the first step in creating these is basically you scrape a lot of text from the internet. You feed a bit of that text into the model. You ask it to predict the upcoming pieces. And through that process, which can cover hundreds or thousands of gigabytes of data, it slowly starts to build up a model of language, what it is and how it works. And in that starting point, you'll generally just have a model that will continue to write on this piece of text that you provide to it. So be the beginning of the story, it can continue to write what comes after, which is good for, say, writing, but not that useful for many other use cases. So you come in with a second step. You kind of change up what you want this model to do. You utilize this previous model of language that it have learned, but now you instead create a data set of, say, a bunch of questions and a bunch of answers that humans have written to those. You put this to the model and train it on kind of replicating this to skew it to, instead of just writing a continuation of a text, can actually write answers to the question you ask or follow instructions, becoming much more useful. And a further step here is also something that can be called human preference or reinforcement learning from human feedback. This is once you have this kind of generic understanding, question following, you might want to align this to follow a specific type of response or preference to write in a specific style. And here you can generate several different answers to the same prompt. As these are probabilistic models, writing the same question will usually generate different types of answers and responses. So you give this to people, you give them the option to kind of say the preference for one over the other of these answers that can be done in a multitude of ways. And then you use that to further kind of push the model to predict and create the type of content you want it to do. So then, of course, what do we use these models for once we created them? And the answer is a whole suite of things. Some more generic models can be used for very diverse tasks, but there are also very specific niche models that have been trained on doing one specific thing very good. So I'm going to cover a few different use cases here right now. And the first one of these, one that got traction early, probably because a lot of the people developing AI are themselves natural coders and software engineers, is applications in system development. And these apps are kind of fine-tuned or created to write code. Can draft pieces of computer code, can help developers identify bugs or automate documentation. And either this can be done through big, I'm sure many people have heard of GitHub Copilot, but I've also heard of people working in large corporations trying to create sort of coding models like this from scratch out of either data privacy concerns or wanting to have it really fine-tuned on their own stylistic guide. So this is a really big use case that increases productivity in a lot of companies a lot. It doesn't have to be this kind of back-end development, though. It can be customer experience as well. So many use cases here can be around augmenting customer representatives, help them draft responses or use questions from customers to more easily find previous answers that have been sent out. It can be automated documentation bots, and this Quinn will cover a little bit more further ahead, where maybe a software system or something else have a set of documentation. And instead of having to go through and read that or ask a support representative, can ask this question to a language model that can provide a sort of answer. But it can also be things such as sentiment analysis, where maybe your company is getting a large amount of reviews for your product or mentionings on social media. And using large language models is much easier to scan through and kind of understand the sentiment of these reviews to make more informed decisions and have a better understanding of how your product is performing in the market. And doing this using language models instead of a huge group of people just reading through reviews might be much more efficient. It can also be within writing. Copywriting, for example, writers can be augmented by getting ideating assistance, drafting a first draft, or maybe improving their writing. It can be for companies that operate across the world that want to have assistance in translating documents. Oftentimes, these models are trained to understand language in a wide array of different types of languages, and therefore have the ability to translate between these. But it could also be things such as, say, personalized advertising, where you have a base sort of template for an ad, and by giving this model information about your target demographics and groups, it can on the fly adapt and write new ads to target those. Another big use case that also Databricks is a big player in, but a lot of companies are interested in, is information retrieval. Companies oftentimes have lots of unstructured information. It can be internal documentation, handbooks, it can be agreements or invoices that you want to have answers to or questions about, because it can really help you steering and controlling your business. And using large language models, it can be possible to search these databases or vast tracts of information using natural language. Or there are other applications such as in legal tech, where feed in a contract and a language model have the ability to kind of identify passages that might pose legal risk for closer review by a lawyer. Again, kind of augmenting or improving how fast they can go through large documents. But there are also problems with large language models. And one of these are what's called hallucination. This is fundamentally due to how models are trained. They're trained on predicting text that seems probable given the input, which is very good in creative use cases. They make up some text that seems probable, but in other applications where factfulness is very, like maybe you have this as a sales bot or for your internal document answering, it's very important this information is accurate. You don't want to end up having your chatbot promise all the customers some sort of discount or return clauses that doesn't really exist, or you don't want it to give you incorrect information if you ask it about last quarter revenue. So how can we address this? A few possible options. Like, couldn't we just train this model only on factful data? Then yeah, and it has shown that training models like this on, say, textbooks or sorting out a type of data that when you scrape the internet, there's a lot of misinformation out there that your model learns to replicate. But if you're going to curate this massive data set, filter out everything that isn't factful, that might be very costly. And it still doesn't necessarily fix the underlying issue of the model in itself just being trained to predict upcoming tokens, upcoming language that is probable, but not necessarily factful. So there is another approach here, and that's to just augment your prompt, the text you put into the model, with the necessary facts to answer the question. It turns out that that is actually a very efficient way of getting the answers and higher fact content to these answers. But like, if I already provide all the facts with the question I ask, like, what value does this bot add, you may ask? So you actually combine this into two different systems. You can first take your query and run it to sort of a search database. Imagine like Google, but defined in a different way, that fetches all types of relevant information and feeds it into a language model that then scans those, extract the relevant passages, and compile that into one response. And here I'm going to hand over to Quinn to walk us through more about the details of how this works.
Exactly. So hallucination has been a very challenging problem for LLM use cases. And currently, the most reliable and cost-effective approach to solve that problem is through retrieval-augmented generation. I'll call it RAG. So basically, instead of asking the LLM, what is SuperAnnotate or what is Databricks, we'll first retrieve the very accurate source of truth from our knowledge base that's well-maintained, and then given that as a context to the chatbot. So this can largely reduce the chance of hallucination, and also additionally, we'll be able to update that knowledge base without having to retrain the whole language model. As we all know, retraining the whole model is very expensive. And here's a very simple diagram, as you can see, to show how it works. So the user-centered query, which typically is a question, and we use that user retrieval model, for example, a vector search, to retrieve the relevant documents, and then prompt the language model with a question and retrieve documentations, and then return a response to the user. And with this architecture, we actually built quite a lot of use cases in Databricks. So let me briefly show you how RAG is being used in our products. Next slide, please. Yeah, thank you. And so this is the first product that we delivered earlier this year. It's a chatbot that you can find on our documentation website, docs.databricks.com. Feel free to have a try. And you can ask questions about Databricks features, knowledge base, and many Spark features. For example, how to use Spark for processing data, or how to load files into Databricks. This is a very typical example of retrieval-augmented generation, where given your question, we will retrieve our relevant document from the knowledge base of Databricks, Spark, blogs, etc. And then we use the relevant documents as context to prompt it to provide you an answer. And one of the kind of implicit advantage of using RAG instead of fine-tuned model is that the chatbot can always return you a link along with the answer. So this turns out to be very helpful for users who want to know more about the answer or feature. Yep. And taking a step further, we actually built more apps. So instead of retrieve the relevant Spark API documentation, which is very general, we can also retrieve the personalized context that's more helpful to the individual users or more helpful to your individual steps. So this is a context-aware system that we built inside our workspace environment. So when you're doing editing of code or use Databricks features in the UI, we can provide more personalized status as a context to LLMs. For example, the SQL query that you are running, or the code that you are trying to debug, or even more complex, the whole data pipeline that you are trying to figure out why it failed a while ago. So in short, through the retrieval of general or personalized information, we can fully leverage the language model, the language and reasoning capability of language model to avoid hallucination and also make sure the information is up to date. Well, with all this excellent enhancement to LLMs and all these moving pieces, like language model, retrieval model, prompts, chunks, you might have a lot of questions in mind. Like, how do we know if we are on the right track of using them? So we need a very accurate evaluation to actually guide our development journey. So let's get to next. Traditionally, the evaluation of a chatbot has been very challenging. So it's both debatable and also time-consuming. Why is debatable? Because different people have different opinions. There's a lack of standard. For example, when we talk about if a chatbot is smart enough, what type of test question that you have in mind? Is it like writing a travel blog, or is it writing a poem, or is it writing a math, or is it answering a math question, right? So I did a small survey in my colleagues. They all have very different personal ways to test LLMs. But as evaluation, we want this to be consistent and standardized. So that's about debatable, and it's also time-consuming and hard to scale. When we want to collect human feedbacks from internal or external customers, we need a time-consuming process to build the whole interaction tech stack to collect that feedbacks. And also we need to do sanitizations, removing PII, to do the filtering and reviews. These are all very challenging, and then SuperAnnotate exactly help us to tackle these challenges. So as you can see from the slides, here is a screenshot of the chatbot grading rules that we came up together after several iterations of discussions with folks from SuperAnnotate. So kind of it's a great combination. As a developer, we know our use case. We know the typical questions and examples that we ask a chatbot, but we're not familiar with how to make this knowledge standardized among people. And then SuperAnnotate provides suggestions on what contribute to a comprehensive grading rule and get back to us with feedbacks. And then we polish on this grading rule on and on after several iterations. And as a result, we got very promising findings. So let's see the next slides. As we all know, standard and example matters a lot for human in terms of communication and collaboration. And our research actually shows that it matters probably even more for LLMs. So many people know that GPT 3.5, the one that you use, is much faster and cheaper than GPT-4, which is the current most powerful model, but it's doing less good in many tasks. And our research shows that by providing more examples to GPT 3.5, you will actually be able to improve the grading consistency of GPT 3.5 and make it usable as an evaluation LLM. And this is very promising commercially because it can reduce the cost of grading by more than 10x. And with the high quality labels we created together, we're very excited to find that the good consistency is maintained both between LLMs, namely GPT 3.5, GPT 4, but also between LLM and human. So let's see the next slides. We found that by using LLM as judge, it can get more than 85% of agreement with human on the grading score. Means like we get the same grading score. And if you lower the standard a little bit to consider like one score difference also as agreement, then we get a very high agreement rate, which is 95. It's very promising. So this is probably the best news in our recent LLM evaluation research, since it showed that we can use LLM as evaluator to replace human in many cases. So instead of taking a few days to get human to label the result, now we can offload a large portion of the grading work to LLMs and leave the relatively complex task to human. And this greatly speeds up our development process. But please keep in mind that before you use LLM as judge, please be sure to ground it by human at least once. This is also what SuperAnnotate will be very good at. And this also was made possible by SuperAnnotate in our previous process. Yeah. So that's all about all the amazing LLM evaluation work that we did together with SuperAnnotate.
Thank you for that, Quinn. So when you have done a lot of evaluation of your large language model, you're doing it for the purpose of understanding, like, how well does this perform? Is it good enough? And what can I improve if it's not? So what do you actually do if your evaluation shows that the model wasn't performing to the standard that you want or to the way that you expected? Well, as Quinn previously went through, RAG systems have a lot of moving parts. It's the kind of structuring of the information. It's how you retrieve the information. And it's also passing this to the large language model together with some context and, of course, the model of itself. And by designing evaluation criteria in a creative and good way, you can actually narrow down where the error comes from. So starting out, if you can identify that the errors that you're encountering are coming from the model itself, like your retrieval system works great, but once you pass the documents to the LLM, it maybe doesn't perform, like answer it correctly. It maybe isn't written in the style that you want. How can you improve that? There are a few different ways to go about this, quite similar to the training process before, but in a little different order. So by starting out, there are a lot of different language models out there. GPT-4 might be one of the most well-known, a very generic model, and that's quite big, quite expensive, but good at following instructions. All the way down to smaller open source models that might be much cheaper to deploy, but might require different types of techniques for prompting and changing it up. So one option here could be change that model out to something other, maybe something more generic. Another approach can also be change how you pose the question to the model. And that can vary again from model to model, and defining and refining exactly how this prompt is framed. So in a retrieval system, that could be something often hidden to the user that says that, this is a question from the user. Here we have a bunch of different documents, and then finalizing that off with some sort of instructions about your style, how you wanted to reference this, and so on. And try out different iterations of that can also be something that can improve the performance of your model. Then, of course, if this doesn't really work, you can fine-tune the model more. And this, when you really, as mentioned previously, you take this example, the questions, get the documents, and then you write an answer yourself the way you want the model to create this. And create maybe 1,000, a few hundred, or more examples. Depends a little bit on the model, on the use case. You can use that to reshape the weights and design of the model to be more likely to produce the output of the types that you want. This is also an approach that can boost performance of less generic models. So a fine-tuned, smaller model might perform to an equal level as a larger generic model that is not fine-tuned, but do that at a lower operational cost. And finalizing, we have the RLHF again. Say that your model is like overall pretty good. Sometimes it does exactly what you want. Sometimes it doesn't. That might indicate that you just have to kind of tune or change the way the model is predicting. and use RLHF, where you create these different responses. You have a human to evaluate this, and then you use that to skew the model to producing this type of responses that are closer to what you want. So these are all different approaches you can take. And what do you do if you think the error isn't coming from the language model? Like the language model, based on the information it gets, is performing great. So then it might be the retrieval step that is problematic. And how this retrieval step is shaped can be very different depending on your use case. So usually the approach is to use some sort of model that transform each piece of your database, of your document, into a vector or a string of numbers. You do the same with the query, and then you plot this in a high-dimensional space and find which one are kind of closest to each other of these embeddings. Like what you can do there, if that is something that suits your system, is it's possible to change this embedding model. It's again possible to fine-tune that embedding model to suit your data set better. Or it might be other things, such as chop these documents up into pieces, and how big are these pieces? And that can also have an effect. But there are also situations with this type of approach, changing the embeddings model or chunk size might only take you this far. You can have a much more complicated data setup where there isn't just similarity in phrasing that guides you right. It might be that it requires hops to several different documents to synthesize the answer, or it might be there are several different types of relationships between documents that you want to be able to capture, like references, cross-referencing, or titles. And that might require you to create a more advanced system, like a knowledge graph, or combine several different search mechanisms to find the documents. Or maybe have the LLM, after the first series of documents, instead of just giving an answer, pose a new question about additional information it needs to fetch. So there's a lot of possible work down here as well. But as mentioned before, all of this requires good evaluation. And the fine-tuning and RAG steps also require the correct infrastructure to be able to do that. So running all this like in Excel or something else might work for a start, but it can quickly come into the point where that is not really feasible anymore. So this is where SuperAnnotate comes in again. And Jason covered this briefly in the beginning, but really what we do consists of 4 main pillars. The first one we call preparation and fine-tuning. This is our software where you can create more customized interfaces to evaluate large language models and a whole suite of other types of AI as well, but for RLHF, for other types of feedback or evaluation. We also have something we call exploration and evaluation. This becomes relevant when you have a large data set. And it is an engine that allows you to kind of query, structure, and manage a data set of LLM reviews, evaluations, or instruction fine-tuning data to search through or scatter your data set embeddings to understand it much better, to cut out parts that aren't needed, or identify exactly where your model is performing lower than expected. It's also a pillar here called orchestration automation. And here it comes in to make this as automatic as possible. It can include things such as when your data set is finished, automatically trigger a fine-tuning job of a large language model, or routing data between experts or internal folks, depending on the complexity. And the fourth pillar here is the workforce. When you're creating a language model, you most likely have a team of people that are quite specialized on what you want it to do, but they're most likely busy doing their actual day-to-day jobs, or just not many enough to accommodate a fine-tuning project. So here comes the fourth pillar, the workforce, where SuperAnnotate can help you source and manage a large amount of people to do your RLHF feedback, or help write instruction fine-tuning data sets. And that can be from generic college graduates to doctors or linguists or lawyers. So really, it can suit your use case. So with this mentioned, I want to briefly take us over to the platform and kind of show what it looks like. So you can build your custom interface in the platform. This is a simple drag and drop UI where you can combine components such as text fields and evaluation boxes to create the interface you need to be able to manage your data set. You can edit all these components, their relationships and options to one another, as well as move on to a scripting stage where you can actually write code to interact with APIs for language models or any other type of internal systems that you have. So let me briefly close down this PowerPoint, and I'll show you a few different examples of evaluations or instruction fine-tuning setups in the platform. I think you're all able to see the screen I'm sharing of the platform as well. And this is what SuperAnnotate looks like when you're inside the tool. I have a few different projects here. Up in the right-hand corner, it's possible to create new projects, such as LLM and GenAI for this. And over on the left-hand side, there's a whole suite of different options, such as team setup, where you have people management and data access management, as well as other things around that to help you really manage large-scale evaluation projects and workforces easy. It's the orchestration tab, where you can set up your workflows, data conversions, work assignment, or interactions with fine-tuning data sets and APIs. And of course, the project tab, where I am in up here. So let me start out here on the bottom and showcase a setup for an RLHF project that I've created in this sort of coding editor. So this is the interface that then a user or evaluator would be able to see. There's a prompt up here, and we're pressing generate. I've hooked this up to two different APIs, the Cohere and the OpenAI. But for an RLHF use case, this would most likely be two different models you're testing out for your company or for your performance. The prompts here can be either written directly by the annotator according to some sort of evaluation guideline, or it can easily be pre-populated if you have a set of items you want to evaluate your data set on. We have two different completions here, and then down here, we can actually rate these in a lot of different things, like how comprehensive the response is, how readable, or an overall rating to the answer. And being in here, there's actually one thing we noticed when working on these large-scale projects, that oftentimes what your model in the end needs is just sort of a preference rating. Response 1 was better than response 2. But when you do this with a large amount of people, you want the responses to be consistent and the evaluation to be roughly the same if it's done by different people. And here it actually shows that breaking this down into several different criteria, such as comprehensiveness, readability, correctness, makes the annotations or the evaluations more consistent over large workforces. And also put you in a position where if you internally realize that another type of weighing or calculation, maybe you want to prioritize comprehensiveness higher than readability. Doing evaluations in this more broken up way allows you to kind of do them once and then be able to change the formula by which you calculate which one is the better, instead of having to go back, change all the instructions, and then work over the entire data set again. Jumping back out here to the projects, it's of course not only for text data sets you can do this. It's also possible to hook up to image models. For example, here it's a Stability AI. You can prompt, select the style, generate images, and then evaluate everything down here, again, by giving maybe stars to items or putting in placeholder, putting in answers to reasons that can again be used to both fine-tune a model or evaluate how well it works for you. And it supports both video and images, code, and a whole lot of different modalities. Again, going out from here, it is of course not only evaluation of responses that is possible. If you want to do real fine-tuning, it might be necessary to have people write data sets, write answers to questions, and that is why we have a setup for that as well. Here I have populated this up with a question, and down here, there's the opportunity for someone to go in and actually write a response, such as header, this is a response. And you can format this with Markdown. Of course, as well, we go over to the preview and have a response here, which allows the setup of creating this instruction fine-tuning data sets to go through a structured workflow of QA, completion, you can have several people look over and really structure and manage this for a large workforce. Much more easy than you would have been able to if everyone were sitting and writing in Word on their own computer. And of course, for RAG examples, it's not only the completion that matters, it is the content and context that is provided to it as well. So here's an example for how you can set up an evaluation of a bot that answers questions based on Wikipedia content. So here I've written in the question, like, when was Tower Bridge built? And our embeddings system or search system returned 3 different documents here. Wikipedia article about London Bridge, which, I mean, it is in London. It's not the correct bridge. We can evaluate to see that, like, is this really relevant? No. Document 2 we got, it's general article about bridges. And document 3 over here, it's actually about Tower Bridge. This is relevant, and as you can see here, it does contain the answer to our query. So we can check this here. Then continue to scroll down, actually see the answer we got from the model based on this. It says Tower Bridge, not to be confused by London Bridge, they are different, was constructed in the early 19th century. That was our chatbot answer. So if we actually look up here, it is indeed the 19th century. It was, however, constructed in the late 19th century. So we can say it's pretty comprehensive answer. It did include us not confused by London Bridge, which might be relevant. So we can give it a high score there, but for correctness, not so much. So we can give a lower score over there. Mark this item easily as complete and jump other to the next item in the process here. So there's a few different ways you can create setups to evaluate and create data sets for large language models. Jumping back to the presentation here, we want to stop for a bit of a question and answering session based on this.
Great. Yes, Leo, thanks so much. Quinn, thank you. Obviously, it's always a pleasure to get an opportunity to work with folks like Quinn and amazing organizations like Databricks at the forefront of Gen AI. And so really appreciate the opportunity to work together on this, and thank you for your time working on this webinar with us. Wanted to get to a couple of questions. So let's start with the first one so the question is, you mentioned that a RAG can reduce hallucinations. Does the RAG system contain a fine-tuned model or just an open source LLM?
Probably I can take that. As we mentioned earlier, like language model is kind of one of the moving pieces of a RAG system. So it kind of really depends on what your evaluation result shows. Most typically, we see that people use fine-tuned model for like a specialized to like be more aligned in certain capability. For example, hallucination being one. It's like wanted to be more truthful. That's one reason. Also, the other reason I see people use it is to kind of reduce the toxic answers. And then the other option is like people just want like a faster response, so they change to a like more fine-tuned smaller models. So I would say it's really depend on like what kind of feedback you get, where the previous system is not doing good enough. Then you choose if you're using a fine-tuning strategy and what type of fine-tuning goals that you want to achieve for that model. Yeah.
Yeah, I think that's very good. Used to add in there when I've been experimenting with different types of models for RAG use case, I have encountered as well there that like might start out with a big model such as GPT-4, for example, that perfectly follows your instructions, cite everything in the right way. But like once you get started, you realize that bill adds up for calling that API over and over again. But then it might be tempting to switch to a smaller model, say Mistral, a cheap open source model, quite cheap to run, but weren't able to follow that instructions in the same way around referencing. So their fine-tuning, for example, can be really efficient. You can fine-tune and shape this model to follow your responses better, and ultimately then have a much lower operational cost. So it might be considerations for cost or for style or toxicity and a whole suite of different reasons, but really ultimately very dependent on your use case. If you're using a standard model that performs great, then I mean, good for you. No fine-tuning necessary in there.
Wonderful. Thanks, folks. The next question is, how is comprehensiveness and readability evaluated?
I kind of exactly kind of encounter this. So this is actually a very interesting topic to talk about. So first, I think comprehensiveness is actually hard to measure. When we do a bunch of experiments, we found that different people understand comprehensiveness differently. Some users might not even need like super comprehensive or long answer. So kind of there's an overlap and also subjective of comprehensiveness. So it's a little bit harder to evaluate, but for readability is relatively straightforward. There's kind of fluency measures. So you can either use the existing out-of-the-box models. I I can't exactly remember the name, but there's like a relatively small model can achieve the rating for readability, and there's a pretty well-defined benchmark for that. And or either you can use like LM at Judge to do it. Turns out the LM Judge is also doing pretty well on this. So kind of there are multiple options. But one thing to mention is that, especially for relatively subject topic like comprehensiveness, make sure that you kind of ground the evaluation with the real user feedback or with real humans, like SuperAnnotate experts results before you try to use like automated solutions. Yeah.
Yeah, and around comprehensiveness there as well, we really had a lot of back and forth discussion into kind of figuring out exactly how can comprehensiveness be rated in this project. Starting out with more generic guide with some examples, running it through annotators that it turned out had a lot of questions. We encountered a lot of different sort of edge cases, and really in the end managed to work out something that, based on the specific use case, like the need for comprehensiveness in the specific use case, the type of questions, figure out a good way to rate this. But again, that is criteria that is very depending on your use case. And as Quinn mentioned before as well, one of the parts that make it so important that a framework for evaluation isn't generic. There isn't one generic framework that works the best for all type of RAG applications. It really needs to be something that is created specifically for the kind of nuances around the use case that you have.
Wonderful, wonderful. Thanks, folks. Another question. This might get a scope. Is there potentially value to add a labeling step in the RAG flow pre-vector database to get more accurate answers/output?
To confirm, what does the pre-vector database mean? Like in the retrieving step, or probably need a little bit more clarification.
Yeah, if I can take a stab at that. If imagine you mean around the structuring of the data, and feel free to ask again. I mean, if I'm getting this wrong, but to a sense, if you mean like label, say, the documents that are used in different categories or different types that can help answer different questions, there might definitely be something that can increase the performance of the system, but it really depends on the document database that you have. In some cases, it turns out that embeddings work really, really well to identify. But I mean, sometimes you want to filter it down more. Like maybe you're searching with embeddings through a database of, say, different coding languages, the documentation for Python and Scala and Java, and just running a sort of similarity search there might return documents for all of those different programming languages and make it difficult for the model to actually discern what is relevant for you. So there might be of huge value to label, say, these are all Python documentation files, these are all Scala documentation files, and then based on the query, you first filter and do your similarity search only within, say, the Python to improve the performance of your model. So it can have a value, I would say. And I hope I understood that question correct.
Great. The next question, let's see, you guys can see it in the chat. How can we handle if RAG systems give different responses to the question? And how can we use the feedback of the responses which are not answered correctly to train our model again?
I guess this probably is referring to the contrastive like training samples. Typically, having like a negative sample is helpful, but in order to make it effective, the better also give it a positive sample. Basically, kind of what's the actual correct answer for this. This will be very effective if there's like a pair or even more than two comparative samples. That's how typically use it. If there's only negative one, it might be able to get values out of it, but there need to be some strategies to make sure that you have some anchor points. Yeah.
Great, thank you. One more question. Does the RAG system check the distribution of relevant chunks for redundancy before sending to the LLM?
So this is pretty much relevant to the retrieving step. There's really a lot of retrieving strategies that you can find online. One of the strategies like this is like you decide the chunk and distribution, or you have smaller chunk to decide the distribution before sending over, or you have a larger chunk. I would recommend to have like a, I would say, personalized data set for your use case and then compare those two. So first, it's definitely doable. It's just kind of a matter of, does this feature or use case more or less? Yeah.
Great. So thanks everyone. Those are all the questions. I think Leo, that if you want to just drop it to move it to the next slide. So thanks everybody for attending. The last few questions were really about, a number of folks asking about, how do we learn more about SuperAnnotate? How do we learn more about Databricks? How do we get our hands, on SuperAnnotate and Databricks? Feel free to email either Leo or Quinn using the email addresses below. You can ping me at jason@superannotate.com as well. Really, again, want to thank everyone for joining. Thank our panelists for presenting. It took a lot of work and it was really an excellent webinar. And yeah, looking forward to see everyone again at the next webinar that we have. So thanks so much, everybody.
Thank you.
Thank you all very much. It's a pleasure.